Good morning. Welcome to this is our first paper that we're having today at this EV Expo associated with the Alternative Energy Association, Technology Association, I should say, shouldn't I? So it's got the wrong thing on there. Right, my name's David Clarke. I was a lecturer and senior lecturer here in mechanical engineering for many years, and I finished up here in 2007, so I was coming back to my old haunt to some extent. And in this paper, I'm just going to quickly run through some basic principles. For example, tool power, because we were all pretty familiar with cordless drills. Pedal power, what happens when we get people on a bike. Bike dynamics, something about what happens when you go along the speed you want to travel at, the slopes and the brakes that you'll be using. And the same thing with car power. It gives us some idea of what amount of energy we need to get hold of. Then we'll talk just very briefly about motor types, engine types, meaning fueled engine types, and motor types, just briefly about electric motors. Then battery types, we'll look at some of those ones there, particularly energy storage and the mass of them. And then finally we'll wrap up with choosing systems, bikes, electric cars and hybrids. And so we'll go to the second slide now. Right, to start this off, you probably haven't seen one quite like that. I rescued that from the hard rubbish a week ago and spoke to the lady that was donating it to an op shop on the way and said, look, I've got something better I can do with it. You're happy for me to do this? So I just turned up a little pulley there to look at doing a belt drive, and I'll also pass this little pack around. I've done a bit of this before, looking at doing a belt drive on the front wheel of the bike. That yellow thing there is just a plastic lid off a tub, and you'll find that as if I pass it around, you can see it's got some holes drilled on it. It's got 6 holes drilled, and they're specifically very easy to just bolt through where the spokes cross over on the bike wheel, so it's very easy to put on there. And I've just got a couple of belts going through there. There's also another lighter power thing that we can think about. Is actually a timing belt drive that's come from a bread maker. My wife, I'll just pass this out so you can just put those past there. So there's just some suggestions there. So now, a few weeks ago, my first line here, I saw a youth in a tinny being an aluminium boat, and he was going around this little lake, and this was at the steam power place out in Scoresby, and I looked over, and what was he was going along, and there he was sitting up there. He had an electric drill in his hand like this, a big long shaft there, and I said, driving a propeller. Well, I presumed the propeller was under the water. I couldn't actually see the propeller, but there he was just sitting there going along at about half walking pace. So I thought, yeah, the idea of something like this is worth talking about. And so think about cordless drills. A little bit of my history is shown in this here. In 2003, my family presented me with a Metabo, quite a nice unit actually. It took me a while to get used to even stop and think about using it. You know, I'm so used to having a drill with a plug-in into the power point. You know, you just grab it. Oh no, perhaps I should use the cordless. And eventually I did use that there. So that was the price of that one at that time. It was a 12-volt system, and it's 1.3 amp hours, so that gives us 16.8 watt hours capacity in the battery. The batteries weigh about 0.65 kilos, the battery pack I should say, the thing you plug on. In other words, if I take that one out of there, that's the part I'm talking about, and they were NiCad batteries. Unfortunately now, they have expired. One battery has expired completely, the other one I can probably get half charge in it, and, you know, use it the next half hour will probably work for me, that type of thing. Okay, a little while ago, I was also given another present, and this time it's a Taurus one that cost $60, 24-volt one, 31.2 watt hours capacity in the battery, and it's an MH, and it's, as you can see there, a little bit heavier, 0.85 kilograms is the battery pack part of it. All right, the next lines, just looking through here, again a little bit of a survey at your local Bunnings store would show you these sort of things. A lot of ones now are 18 volts lithium ion, and there's a readily available range there. The Zito one starts off with a range there at $78. It has 23.4 watt hours and a 1.4 kilogram, that is battery length. In other words, it's something looking like this. The whole unit weighs 1.4 for that one there, and it comes with 2 batteries. If you go up market a bit more, you've got Bosch, 27 watt hours availability out of a single battery, 1.3 system weight there, and they supply them with 2 batteries. Makita one, 249, a little bit less in the kilowatt hours, also the watt hours available there, 1.6 kilogram system, but they do supply 3 batteries. And if you go AEG, a little bit, another $20, you'll get one with a 3-year trade warranty. Now, I guess the decision you make about which one do you buy, do you say, I'm only going to buy the cheapest one, which of course is what I'm talking about. But for someone whose livelihood depends upon having a reliable unit, obviously you goes up market. So there's just...
Is it worth paying?
Well, I think you've got to say, do I need...
3 Tauruses.
Yeah, exactly right. You've got, well, you get 4 Tauruses if you go down the bottom of the line there. But yeah, so that's the sort of thing that you've got to make a decision. The decision is how much money do I spend and how hard do I want to use the thing. And so I'm quite happy with the Taurus, and I'll continue to be like that. Now, when we come to pedal power, hello Jack, you're sitting in the front there. Did you notice I used you as an example? Jack's in his 80s. I won't ask him exactly what part of his 80s he's in. But
You're talking about me.
Yeah, is that all right? You're not going to hit me? You're not going to hit me?
No.
No, but Jack, about 12 months ago or something, you went out and got a front wheel electric drive for your bike, didn't you?
I'm 86 and it's keeping me cycling.
So there we go. So that was the point I'm making there. All right, now, the next line says pedal power. How much pedal power can we expect to do? I started off on this many years ago when I was here at Swinburne, and one time I gave my students the design problem to have a pedal power washing machine. And so we got a cycle ergometer in, and we got them to try out. And there were some who could instantaneously do 1 kilowatt, no worries. Now, later on, they didn't like me doing that, so I think there's some possibility you might get trouble with people exerting themselves too hard for too long. But this is for long-term type data. For about 5 minutes for an average, a reasonably fit male, but not a super fit, not an athlete type of thing. 300 watts for about 5 minutes is what you expect an ordinary person to do. 1 hour, about 200 watts, and 5 hours, about 100 watts. So those are continuous ratings there. And so I looked up some information regarding a sports bike, which would be maybe a 10-speed, 12-speed, 18-speed sort of bike there. And what do you need to actually ride that along a road? So speed on the level, at 20 kilometres an hour, you need about 60 watts input. At 30 kilometres an hour, you need about 160 watts input. And if you want to ride at 40 kilometres an hour, you need 360. And so when you see numbers like that and you compare how much can I ride for 1 hour, like let's say I'm useful for 200, then if I want to ride at 40 kilometres an hour, I really need an electric assist to make me get up to that speed. Now, the other thing is, what about the slope? Now, a 1% slope is a very small slope, really. It's useful sometimes to know that 1 and 2% are sort of railway gradient type things. Rail, like that. And I also, amongst other things, I tow caravan. And I remember going to past a place in Victoria a couple of years ago, and I thought to myself as I drove down this hill towards the destination we were going at, I thought, do I have to drive back up that hill and drag my van up? And that's how I think. And here, while I was there, I asked them some questions, and somebody said, no, you don't go back that way. Go out through another one there, and what was that? It followed a rail trail, virtually. And it was a much simpler way, and I just thought, that's a very useful bit of information. And if you're riding a bike, that's why rail trails, I suppose, are pretty good, because they actually very slow. So anyhow, in this case here, I put the plus and minus there because obviously if you're going up a hill, you need an extra 44 watts at 20 kilometres an hour. If you're going up a 2% grade, you need extra 88 watts, and so you can add those things as you go across there. So you can see on the right-hand side, if we're going fast, we need some significant amount of power to do it. The other thing is the acceleration. We probably don't think so much about this in bikes, but I did it because we need to think about it in terms of motor cars later on. But the acceleration says that if I'm going to get up to 20 kilometres an hour in 10 seconds, then I have to put in an input of 120 watts continuously over that 10 seconds to provide the extra kinetic energy of my bike. And I also have to, of course, when I get to the 20 kilometres an hour, if I'm still accelerating, still 120 that I'm putting in there, plus the speed if I'm on the level, for example, or the speed because I'm going up the slope as well. So they all add together. The other thing is to say, well, when we're going at speed and we want to stop, we come into braking. So if I want to brake from 20 kilometres an hour in my bike and stop in 2 seconds, it's an average of about 600 watts being used energy to brake the bike. If I want to brake, say, in 4 seconds from 40 kilometres an hour, it would actually require 1200 watts power. So maybe you need some reasonable brakes on your bike as well. That's what that's saying there. The solar racer. Now, I'll have to amend this because I found that's not quite right. That's my best information. I talked to Jim out there with the solar racer today, the Aurora one there, and he reckons 2 kilowatts is probably better for that one there. So there, and it's useful to look at that because, you know, firstly, it's very low drag coefficient, around about 0.05. Yeah, 0.05, yes, 0.05. And minimal frontal area, all the right things if you want to go fast with using a little bit of power. And they also have some super motors in there, very high efficiency motors, like 98% efficient, I think. So it's worth looking at solar racers just to give yourself a bit of information about that. You may never be able to afford one, but at least, and you may never want to ride that one around the roads here. You might want a police escort, mightn't you, if you're doing it around Melbourne, I think. Okay, now let's look at passenger car power. And my first little quote there is, Nissan Leaf keeps up with all cars on green light. That's what Michael Jacobs said to us. We've had him speak a couple of times, and I've also used him outside to both a men's lunch at the retirement village where I live, and also as a Probus group. We had the Nissan Leaf at the Probus group, you know, all the old ladies loved it. I was so surprised, you know, because it's the idea of a car, you never have to put petrol in the car anymore. You just go home and plug it in and get recharges, and so it makes a lot of sense to people there. But that's what he said. He kept up with all cars there. Some of them decided to get off the lights pretty quickly. What does he do? He just put the foot down and away he goes. And the Nissan Leaf, he just was able to keep right beside anyone else that wanted to roar off from lights. So how's that for a bit of a testimony about it? Now, if we look at these passenger car power, what amount of power do you need to do it? This is what we're going to look at there. Make a couple of assumptions. A 2 square metre area, frontal area of a car, which is fairly typical. 1,000 kilometre mass in here. A lot of our cars will be heavier than that, but it's some figures that I could start off with getting fairly readily. Now, if we're driving a car along at 40 kilometres an hour, you know, past schools and things like that, a sedan needs about half a kilowatt of power to actually drive at that speed. If you go at 80 kilometres an hour, it goes up to 4 kilowatts, and if you 120 kilometres an hour, about 13 kilowatts. And notice how that power is going up and climbing up fairly quickly. That's because it's a cubic relationship. In other words, your power goes up. So if you double your speed, you need 8 times the amount of power compared there. If you're a sports car and you've got a lower CD value, then you might find those values are somewhat dropped down a little bit, but not a great difference there. And when we come to driving on slopes, the same sort of thing here. A 5% slope is a reasonable slope, and as is 10% is even more. So there's some numbers for you there. At 40 kilometres an hour, 5.6 kilowatts you'll need to actually drive the car up the slope, and at 120 kilometres an hour you need 17 kilowatts. If you go to 10% slope, sometimes we don't tend to say in Victoria what the slope of a road is, but up in Queensland they occasionally in fact tell you that. They tell you you're going up a 10% slope. And so having driven up there, I can relate a bit to that. For example, 80 kilometres an hour, you need about 23 kilowatts to drive. And driving up there in Queensland, we had a Camry some years ago, and I remember at that 10% slope, it was about right for a fifth gear full throttle would hold on the hill at about 80 kilometres an hour. So that it says saying that 23 kilowatts provision was about right. Now, when we come to accelerate a car, we want to get up to 40 kilometres an hour. If we do that in 15 seconds, we would need just 4 kilowatts averaged out over that 15 seconds to get there. If we want to get to 120 kilometres an hour, we need 36 kilowatts over the same 15-second period. Likewise, if we are braking, just notice what we need here. If we're going to brake from 40 kilometres an hour in 2 seconds, which in fact you can do, about 30 kilowatts of your brakes all the time that they're braking. And if you do the same from 120 kilometres an hour in 4 seconds, which again you can also do, you need 136 kilowatts of power on your brakes over that time. So brakes are very important. Now, with all these numbers I've given you there, you need to combine all the power demands together. So, for example, if you're going up a slope, you need to add that amount of kilowatts in there. If you're going down a slope, then of course you can potentially, and this is where electric cars are quite thoughtful about this, we can recover that sort of energy which is going downhill, which otherwise goes into our brakes. Again, I'm just talking about driving there. Some years ago in the Camry, we did a trip from Cooma past Thredbo and across to coming out to Albury eventually, around that way. And there's but once you get past Thredbo, there's roads that, as I recall it, are basically you're driving up or you're running down a hill, driving up, running down a hill. And I was rather interested. We did quite good fuel consumption there. And I looked at back there, I was probably driving at about 80 kilometres an hour. I was either going up a hill with the flat down, or I take the foot off as I go over the crest and run down the next one, and so on. And so that's really not a bad way to run a car if you can. It means that you are not running terribly fast, but you've got maximum power on, and that's pretty much where your most best efficiency point will be for your engine. So that was quite surprising to me. Combine all power demands together. So that's that one. Okay, now when we get on to now some vehicle parameters, the first thing, see, we're so used to fuel, and I thought it was worth saying what this means for our petrol engine ones. If you get values of about 220 to 230 grams per kilowatt hour from your engine, you're doing pretty well. The 220 corresponds with 39% efficiency, and the 230 is about 37% efficient. Now that's the very best you're going to get out of the whole of your fuel map of your car. Now liquid fuels, of course, they store a lot of energy, and so here we are. Liquid fuels generally around about 42.5 megajoules per kilogram, and that relates to about 11.8 kilowatt hours per kilogram. And so when we come to some car battery storage things, you'll see that they don't relate to very many kilos of fuel, right, as storage. Now you can do better with engines. Diesel engines will be better, and turbochargers will also help push that up. And so now that we look at battery parameters, lithium-ion ones, I found some information here that sort of said that if you use them in a hybrid electric vehicle, you can expect to get somewhere between 2 to 3 kilowatts per kilogram for lithium-ion, and the watt hours is around between 60 and 80 watt hours per kilogram. If you use them with a plug-in hybrid electric vehicle, that tends to come down a bit. Now I can't tell you quite why that's the case. Notice that you don't get so many kilowatts per kilogram, 1 to 2, but you do get more watt hours per kilogram. So I can't tell you quite why that's there, but they were some figures that I think are fairly reliable. I thought I'd better compare the NIMH one there. Remember I said before the power drill I was talking about, the Taurus one is NIMH battery. And so that's fairly much in the 1 to 1.5 kilowatts per kilogram and about 45 watt hours per kilogram, somewhat significantly lower in both than compared to lithium ion, which I guess you probably will know that anyhow. Electric motors. Electric motors, for me as a mechanical engineer, were clearly quite fascinating. I used to get my students to actually do a bit of work on this, because to look at the actual characteristic of an electric motor, just of the normal AC motors. And I said to them, you know, look, you can double the power out of an ordinary electric motor if you want to. However, you've got to know that it's only a short-term thing, all right? So, and working in the mines, I saw a very interesting example this one time. We had just underground coal mine in Queensland, and there were 2 different shuttle cars being used. One had the normal traction engine drive, electric drive, on the end of it, big long power cable, and the other one was actually a hydrostatic drive. That was a hydraulic drive that would drive a hydraulic motor. And in that particular day they were working, they had a fairly steep climb out there, like perhaps a grade of 1 in 3 or 1 in 4 or something. You know, every time electric one won because it could go into overload. And up it came up that hill, they didn't worry it, you know, and then it got on the more or less level and went back to where its dumping point was. And of course, you could pay off with the, you know, the lesser load it requires there. It's not generating so much heat in the electric motor. And as far as electric motors are concerned, yes, you can get very high efficiencies, but I suppose I just need to put the proviso there to say that it's with exotic magnets, which cost you a lot of money. Okay, so while you can get 98% efficiency type motors, you'll have to pay them for the privilege of doing that. Well, let's now look at choosing systems. Well, with bikes, you've got a front wheel drive arrangement. Probably the simplest way you can actually do transition on a normal bike. You can have a crank drive, and you'll see some around outside. It's worth taking a look at to see that there. Or rear wheel electric drives. You also see some of those with rear wheel electric drives in there as well. There. Now we've also got some of the pure electric cars. So we've got a MEV out there. We've got a Leaf. Just as well I picked up their data, wasn't it? Interesting thing about those ones there, to summarise it, the MEV, the little Mitsubishi one, its battery has a capacity of 16 kilowatt hours. It has a 47 kilowatt electric motor in it, and it has something claimed up to 155 kilometre range. Now whether you get that depends on how hard you drive it, obviously. The Leaf has a larger battery, 24 kilowatt hours, 80 kilowatt motor, and something of the order of 140 kilometre plus range. Again, under standard conditions. That Leaf, from what I can understand, about half the cost of the Leaf vehicle is in the battery and control system. So, quite expensive. Now let's look at a couple of the hybrids. Prius C I've put in there because it's probably not a bad little car in a way. You see a few of them around there rather than the big brother Prius that you're probably more used to. Look at the size of that battery. 0.9 kilowatt hours, and it's a nickel metal hydride battery in there. It's got a 1.5 engine, and it's 45 kilowatts electric motor, and it gets you use about 3.9 litres per 100. I'm sorry, I didn't put this flash 100 there. I was running out of space to do it. The Jazz has come on the market more recently, the Jazz Hybrid. Look at its massive battery. 0.6 kilowatt hour battery, only 2/3 the size of the Prius one. 1.3 engine, only a 10 kilowatt electric motor to drive. And it still guzzles up 4.5 per 100 on that one there. We have a Volt out here. I haven't looked terribly carefully at the Volt, but it's got a fairly big battery in it, similar to the MEV size and not as big as the Leaf. a 1.4 engine, as far as the petrol power is concerned, 111 kilowatts electric motor in it, and that does make a claim that it can actually drive in electric mode for 87 kilometres. And if you run it further than that, you're looking at somewhere around about 4 litres per 100. Now, Volkswagen XL1, anyone heard of that? Only in the last few weeks have I heard about it. Now, it has got a battery of 5 kilowatt hours in it. It's got a 0.8 litre diesel turbocharged engine in it. It's got a 21 kilowatt electric motor, and the claim for that is 0.9 litres per 100, under 1 litre fuel per 100 to run. Problem with that is it seats 2 people. You have to be fairly friendly to fit in the car and so on. But you know, it shows what you can do if you really want to push something to the limit there. Okay, what's the final decision in choosing these systems? Well, I think it boils down to a number of factors. People, like for my wife and I, mostly we only one of us or 2 of us in a car, but we have 3 grandchildren. We see them quite regularly, so our car must be able to take 5 people. Right? What distance do we travel? We don't travel a lot. You know, so an electric car would actually do us quite well for most of the things you do, apart from when you want to tow a caravan. You go reasonable distances. How often do you do it? Well, that's the thing that you have to answer. Another thing is, what is your investment? How many dollars are you prepared to throw at your investment you're making? And then finally, what are your preferences? So you might look at something out there and you say, well, it costs more as an investment, but it suits my style of what I want to do there. So I can't tell you what the answer to all those things are, because it's very individual, I think, but I hope that's been a useful bit of guidance for you and something to give you some facts and figures that perhaps you can help to use to make a decision. Thank you very much. Anyone got any questions? I might just show you, if you want to know some sources of information, can we get this document camera going? What do we got to do with that, maybe? Just turn the lamp on, or we just hit that one there, document camera, PC there. Here we go. Right here, okay. These are some books I got from Superman Library. This one here is Electric Bicycles, A Guide to Design and Use. Fairly recent book, in the middle 2000s, 2005 or something. And there's a series of these ones here, electric and hybrid electric vehicles. There's actually 5 in this whole set, but this one here, overviews of viewpoints, is a starting point. Batteries, that one I talked about, some of those sizes of weights of batteries came out of that one there, and engines and powertrains is another one there. So there's just some sources that are available in there. So I just thought that was worth just showing to you there. Okay. So we just turn that document camera off. Is that right? No, not sure not to. All right. Yes. Okay.
Just wondering about what sort of exotic magnets that make it more efficient.
Oh, yeah. I don't know. Something with titanium. Probably some of the people more up in battery technology. Oh, sorry, in motor technology. Talk to James out there on the Aurora stand, because they'd be the sort of people who would invest in those sorts of motors to get the very, very high efficiency. But they're generally sort of rare earth magnets now. I can't tell you what the formulation is.
Like in space age.
It is, yeah, pretty much that. That's why they're expensive.
They're very expensive, but they shouldn't be.
Oh,
It's totally recyclable.
okay, yeah, well, I guess it's how many they're making now and whatever. All right, any other questions?
Why would people, I've had a Prius and I've got a Camry hybrid.
Have you? Okay.
Why would people be interested still in getting better fuel efficiency out of a petrol motor, which in itself is a good idea?
Yes, yes.
When they can get an electric car which gives them free fuel.
Yeah, well, that's not quite free fuel, but yeah, I know what you're saying. Look, I mean, if I looked at that from my way I answer that question personally would be, I would find the Nissan Leaf, I think, a very attractive car to buy. Well, maybe to buy. Maybe I'll wait till it's second-hand for a while. And then, because for most of my driving around, it would suit us fine. 3 grandkids can go in the back. My wife and I can go in the front. It can run around the roads just like I would normally do. It would be very nice. And I can go home each night, plug it in if I need to charge it up. That would suit me fine. But when I want to go away for a holiday, what do?
Yeah, hire a car.
Or else, well,
How
maybe.
often do you go?
Well, okay, maybe 2 or 3 times a year. Okay, but no, what I would probably say is that in our situation, I've got locally a daughter and a son there. Maybe we say, please can we swap? We'll take your car away for a while and you use our electric. That might be a way of making it work. So from that point of view, I think I would find that fairly attractive. If I'm paying money to buy it, maybe the Prius C might be a more attractive proposition because you're not up in that high range of the normal Prius. But you said you've had a Prius. Do you want to give some comments?
I've still got a Camry hybrid. No, I've just bought an iMode.
iMode, have you? Okay.
And I also have a Blade. So
And a Blade.
one out there.
Oh, okay.
But I can tell you about the figures for the iMode.
Well, yeah, well, why not? Are you happy to hear with? I mean, that's
I have one
good.
from the Victorian Electric Vehicle Trial. You can go to their site and see all those figures.
Yes.
But just from my own practical experience, it does 100 cars.
100, okay.
I mean,
So-
I could get 150 out of it. I really pushed it. But
So you think this is probably the top end of the range?
If I wanted to.
Yes, yes,
But 100's a general. When I fill it up, I'll get 100 out of it.
yes,
I've driven this one from Ballarat to Wangaratta, which is 360 kilometres.
yes.
And I've driven a couple of them down the back from Wangaratta to Melbourne.
Yes, yes.
And I can get 100 k's most of the time.
So going from Ballarat to Wangaratta,
It took me 24 hours.
how many recharge stops did you have?
Well, as I say, I charge every 100 k's. Right?
Okay, yes, yes.
I charge at Seymour and Benalla.
And where do you actually charge it?
Well, that'll be a long story. I don't want to bore
No,
everybody.
but yeah,
I bought the Blade from Ross Blade.
yes,
So when I drove from Ballarat, I drove to Chewton, where he is at the moment. I charged there.
yes,
And I talked to him all day about blades, which was very interesting.
yes,
And then I drove from there to my daughter's place at Lansfield,
yes,
charged there.
yes.
Had the normal father-daughter relationship. We had arguments about everything. And then I took off to Seymour, which is a short trip.
Yes,
And I slept in the car while I charged,
yes.
which was a bad mistake because electric cars are very quiet, except when the iMode is charging, every 20 minutes the fan comes on to cool the batteries. So I now carry a pair of noise-cancelling headphones. But as I say, at 100 k's, a good way.
Because okay, yeah, sure.
And I've got a deposit on a Tesla S, which is the ultimate car.
Frank, you'd be the only one with an electric car that has noise cancelling headphones.
That's true.
Can I ask with the charging business? So are you able to, like, do they have special charging equipment? Like, are you
Well,
going to place or?
With the Blade, it plugs in an ordinary 10 amp GPO. Just plug it in there. With the iMode, they supply a cable which plugs into a 15 amp.
Okay.
Or if it happens to be a double 10 amp, you can file down there. It's got a 20 amp fuse on it.
Gee.
And it might get a little bit warm because the wiring's not too good in there. But I charged last night at the Novotel, and they had a single 10 amp, and I checked it periodically, and it warmed very slowly. And they probably had, being a hotel, they probably required that 15 or 20 amp fuses.
I understand the iMove is actually current limited to 9.8 amps or thereabouts.
Oh,
So
okay.
10 amp output is fine.
Right.
Okay.
Gentlemen, can I spoil the session? But we've got our next speakers who are going to talk about the Antarctica project. We've got a solid goal. These young guys,